Hi everyone, and welcome to week 3 of iolite's Python for LA-ICP-MS course. My name is Petrus, and I will guide you through the first part of this week's lesson that will culminate in writing your first importer for iolite. Let's begin with an overview of the different topics we will discuss today. First, we'll have a quick review of the basic types and most common features of the Python language that you should be familiar with from weeks 1 and 2. Starting this week, we'll be using these building blocks to interact with your data in iolite. If you are struggling with a concept, please do not hesitate to contact us for additional help via the forum. Next, we will talk about Python packages, which provide additional types and features to Python beyond the basics that we've already learned about. We will then turn our attention to iolite's Python Application Programming Interface, or API for short. As you will see, this is a powerful way to interact with and manipulate your data in iolite. Next, we will talk briefly about how Python plugins work in iolite. Lastly, Bence will guide you through an example iolite importer and provide details for this week's exercise. You can probably already appreciate that this week's lessons will cover a lot and perhaps be a little more challenging than the first 2 weeks. However, if you stick with it and ask for help when you're stuck, you'll be well on your way to mastering Python in iolite by the end. From the first 2 weeks, you should be familiar with the following Python concepts: variables, expressions and statements, conditional execution, functions, loops and iterations, strings, files, lists, dictionaries, tuples, regular expressions, and object-oriented programming. To check your comprehension, consider the Python code shown here. You should be able to read this code and predict what the output will be. If you like, you can pause the video now and try to figure it out before I go through it. So here we have a function definition called review1 that takes 2 parameters a and b. When this function is called, a variable c is assigned the value of a less than b. We then have a conditional if statement that prints a different string based on the value of c. The function then returns the value of c at the end. Outside of the function definition, we have a print statement that will print the return value of review1 called with parameters a equals 1 and b equals 2. So when this runs, c is true, and therefore the function will print a is less than b, but it will also print true. Here is another review function to test your knowledge of Python basics. Again, we print the return value of our function, in this case called review2. When the function is called, parts will be a list of strings containing 3 items, LA, ICP, and MS, because we are splitting the entire string based on a hyphen. When we use enumerate in a for loop like this, we will get each part but also the corresponding index as I. So when this loop executes, we'll print part 0 is LA and has length 2, part 1 is ICP and has length 3, and part 2 is MS and has length 2. But since we are also printing the return value of this function, we will also see each of the strings enclosed in square brackets. One final review script is shown here. At the top, we have a function definition for a function called review3 that takes no arguments. Inside that function, we create a list of letters containing A, B, C, and D as strings. We have D being a blank dictionary and I being the integer 0. As we loop through each letter in our list of letters, we insert the letter as a key in our dictionary and give it a value of I. And each time we go through this loop, we're going to increment the value of I. We then return this dictionary. So down below here, we have D being this dictionary that we've just constructed with keys from A to D and values from 0 to 3. We then insert another key, E, with a value of 4. So when we encounter this print D, we're going to see the stringified version of this dictionary containing keys from A to E and values from 0 to 4. But when we encounter this final print statement and we try to print the value for the key of F, we'll encounter a key error because that key is not in our dictionary. If you were unable to predict the output of each of these review functions, you may want to go back and practice the fundamentals a bit more before moving on. Now let's turn our attention to Python packages. As I mentioned during the overview, packages are a way to extend the functionality of Python beyond its built-in types and functions. There are literally thousands of packages that allow you to do almost anything with Python. If you've followed the Python for Everybody lessons during weeks 1 and 2, you've already used a few packages, for example, the regular expressions package. Using this package provides powerful string parsing features that are not part of the Python language itself. The regular expressions package is part of what's known as the standard library. This library consists of many packages that are included by default with most Python installations, including the one bundled with iolite. Python has what is known as a batteries included philosophy, which means it is capable of a variety of things out of the box, which is not true of many programming languages, and one of the reasons why Python is so popular. There is comprehensive documentation available for the standard library at docs.python.org/3.8/library. This is the documentation for the Python standard library. Here you can see many relevant packages for getting data into iolite and working with it once there. For example, date and time manipulations, mathematics and statistics, finding and parsing files, delimited text, XML and compressed file handling, network requests, and so on. We will not talk about any of these in detail now, but they will be covered as needed in this and later lessons. A more approachable introduction to the standard library can be found in Python's brief tour of the standard library. Here you will find short snippets of code that show off some of the more commonly used features. Beyond the standard library, Python has a wonderful ecosystem of data science packages. Some of the key data science packages are listed here. NumPy is self-described as the fundamental package for scientific computing in Python. Notably, it provides an array object and an assortment of fast routines for operating on them. Pandas is described as a data analysis and manipulation tool. Think Excel, but in Python commands. SciPy builds on NumPy, providing algorithms for things like fast Fourier transforms, interpolation, optimization, and so on. Matplotlib provides comprehensive visualization functionality, and lastly, scikit-learn provides machine learning algorithms for classification, regression, clustering, and more. Links to the relevant documentation will be included in the notes accompanying this video. Since we'll be using NumPy and Pandas in the exercises later, we will now have a very quick crash course on how to use them. Of course, more documentation and an endless number of examples can be found on the internet. Customarily, NumPy is imported as NP. Then, we can create array objects using NP from a list as is shown for A, or using a generator such as zeros, ones, or linspace as is shown for B, C, and D. As the names suggest, zeros and ones will create arrays of zeros or ones with the length of the array specified as a parameter. Linspace takes start and end arguments and generates the specified number of evenly spaced items between them. Once we have NumPy arrays, there are many built-in functions that can operate on the array objects to tell us something about them. For example, the mean, max, or sum of the values in the array. Individual values or ranges of values can be accessed in an array using square brackets, remembering that the first item is indexed as 0. So, in this line we are setting the first value of A to be -1. On the next line we are adding 10 to the values starting at index 2 and going until the end of the array, as indicated by this -1 here. Here we are doing some array math, multiplying array C by D, adding it to A, and assigning the result to F. And lastly, we can square each of the values in an array as shown here. Hopefully this gives you an idea of the kinds of things you can do with NumPy and how the syntax is quite logical. We have only just scratched the surface of what is possible. To find out more, please see NumPy's Quick Start Guide at the URL shown here. Now we will turn our attention to pandas. Similar to NumPy, we will import pandas as PD to begin. Now we can create data frames a variety of ways, two of which are shown here. In the first instance, we are creating a data frame from a dictionary, where the keys will be the column names of the data frame. In the second instance, we are creating a data frame from an Excel spreadsheet. Note that once you have a data frame, there is a similar function to write it back to an Excel file. Once we have a data frame, we can do similar things to what we just did with NumPy. For example, we can calculate the means, maximums, and sums of each column of the data frame as shown here. You can index a data frame with square brackets. To retrieve a column, you can supply a column name, or you can get a row or range of rows by providing a number or slice. You can also retrieve part of a data frame using Boolean indexing. Here we are selecting the rows where column A is greater than 2, and then adding 5 to each of the values that match. Lastly, we can add a new column to the data frame as shown here, where we have created a column C that is equal to the square of the values in column B. As you look forward to manipulating your data in iolite, these basic features of NumPy and pandas should look very appealing. Many packages are bundled with iolite, including everything mentioned so far. There are, of course, many more packages that are not bundled with iolite. You can find most of these packages on the Python package index at pippy.org. Note that it isn't always straightforward to install additional packages for use with iolite. If you want to do this, please contact us first. You can find the path that iolite will load Python packages from by going to iolite's Preferences, and then to the Paths section. The path to look for is the Python site packages. This is a semicolon delimited list of paths because there is more than one location that we must search. If we were to navigate to the path ending with site packages, we would find NumPy, pandas, SciPy, and many more packages that are bundled with iolite. One final package I want to mention before we move on is Qt. Qt is the library that we use to build iolite's user interface, and you can access it from Python by importing widgets from iolite.qt.gui. Note, however, that packages depending on Python bindings for Qt will likely not work without some modifications. We will talk more about this next week as we use Qt to create a settings dialog for our QA/QC module, but I thought I would point it out now for those that are looking ahead. At this stage, we know about the fundamental types and features of the Python language, and we have a basic idea of some of the key data science packages. Now we want to use our Python skills to interact with iolite. This is where iolite's Python API comes in. API stands for Application Programming Interface, and it is really just a set of objects and functions that you can use in your Python scripts to interact with iolite. These scripts can range from simple one-liners to complex data reduction schemes and user interface plugins. There are many ways you can use the API, but the majority of them start with the data object. If you are familiar with the core concepts in iolite, like time series data or channels and selections, as well as the basics of Python, the API should feel fairly natural. I'll show you how it works with a quick demonstration in iolite. I have loaded our frequently used otolith example dataset. I have set up selections for the background NIS612 and the otolith. I have also run the trace elements data reduction scheme. Now, as I mentioned, most data access is via the data object. So, to get a time series data object from iolite, we can do channel equals data.timeseries with the channel name as an argument. In this case, I'm going to get uranium-238 ppm. Now I can do channel.name to get the channel name. I can do channel.properties to get the channel properties as a dictionary, and I can do channel.data to get the channel data as a numpy array. Similarly, to get a selection group object from iolite, we can do group equals data.selection group, followed by the group name as an argument. I'm going to get group NIS612. Now I can do group.name to get the group name. I can do group.count to get the number of selections in the group. And I can do group.selections to get a list of selection objects associated with the group. Now I can get a selection object from the group by doing selection equals group.selection, followed by the selection index as an argument. I can do selection.name to get the selection name. I can do selection.properties to get the selection properties as a dictionary. And I can do selection.startTime to get the start time as a QDateTime object, and selection.endTime to get the end time as a QDateTime object. Now, with a selection and a channel object, we can retrieve a result object from iolite by doing ppm equals data.result, followed by the selection as the first argument and the channel as the second argument. Now I can do ppm.value to get the result value, or ppm.uncertainty to get the uncertainty of that result. Using these features and what we know about dictionaries, lists, and pandas, we can make a data frame of our results. Since this is a bit more code, we will do it in iolite's Python workspace. To build up our data frame, we will start with a blank dictionary D. We want to fill this dictionary with keys that are our channel names, and each row representing a different selection. To do that, we'll use a for loop to get every output channel. Inside the channel for loop, we will start a blank list. Now we will use another for loop to visit each selection of our group. Inside the selection for loop, we will append the result value to our list. Finally, we can insert this data into our dictionary. Now, creating a data frame is as easy as calling pd.dataframe with our dictionary as an argument, being sure to import pandas as pd at the top. Now we can run this script by clicking the Run button in the top right corner. If everything has gone as expected, you will find a df object in our object tree shown on the right-hand side. We click on that, then on the Data tab, you can see the data that is now in our data frame. There is an even easier way to get a data frame from iolite. If you have a list of selections, and a list of channels, you can simply call data.frame, where the first argument is the list of selections. Then we have a list of selection properties that we'd like to include as columns, followed by the list of channels, and a list of channel measurements that we'd like to include. Here we'll include the mean and 2 standard error. Now, we have our data frame. We could write that data frame to an Excel file by calling df.toExcel. and specifying a file path as the first argument. Here you can see that we have that data frame in an Excel file. We can also manipulate the time series data. So let's do a bit of that. We can get the uranium-238 channel data by doing something like this. We can also get the time array for that by getting the time series object and calling .time on it. Now we have the U238 channel data as an array and its time as an array. We can create a new time series data object, new time series channel, by specifying a name, its type, time array, and a data array. So now, if we come to the time series view, we should have U238 times 2 in our list. We can also replace channel data. So for example, if I did U238 and I took all the U238 data that was less than 1000, I could set that equal to -1. Now, we come back to this view and zoom in. You'll see that everywhere that the channel was low is now at -1. There are several resources where you can learn more about the API and see it in action. For example, our documentation website, our GitHub examples repository, our notes website, some Python scripts that are bundled with iolite, as well as the forum. Let's have a closer look at these resources now. iolite's online documentation can be found at iolite.xyz/docs. When you navigate there, you will find a link to the API documentation in the left side panel. When you click on that, you can see information about the different data types and functions that iolite exposes to Python. For example, if we wanted to learn more about the create time series function we just used, we could search for that and find out what the parameters are, and what it returns, and any other notes that we may have made about that function. This is iolite's GitHub repository. Here you can find examples for each of the different plugin types, among other things. You can browse the repository online if you just want to study the code, or if you want to download the entire repository, you can click the green code button and then download zip. Or if you want to download a single script, you can navigate to that file, click the raw button, and then save that page as a Python file. Our notes website can be found at notes.iolite.xyz. Here you can find short tutorials and demos, many of which use Python. You can find just the Python-related ones by clicking on the Python tag. Then, for example, if you wanted to learn more about synchronizing data in Python, you might want to check out this note on synchronizing individual laser log samples. It contains some information and examples on the topic, including Python code snippets. iolite comes with a few plugins that are written in Python, and they are great examples of the more complex things you can do with the Python API. This is iolite's default documents folder. If I go to the plugins subfolder You'll find data reduction schemes, importers, QA/QC modules, and user interface plugins. If I go to data reduction schemes, you can find the Python source code for the newly released 3D trace elements data reduction scheme. Open that up, my favorite editor, and browse the source code to learn more from it. Finally, our forum, located at forum.iolite.xyz, is another resource where you can find questions and answers about the Python API. Note that there is a Python tag to help you find Python-related content. If you are posting a new discussion, please be sure to use it. As with packages, there are a few things worth noting about the Python API. First, don't assign anything to data. Nothing bad will happen, but you will lose access to iolite's main data access and manipulation mechanism. Second, with great power comes great responsibility. Yes, you can access the raw channel data, but you can also erroneously overwrite it. Also, if you're not careful or find a bug, it is entirely possible to crash iolite. And to reiterate again, you really shouldn't run any scripts that aren't from a trusted source without first reading and understanding them. Third, we add to and refine the API with almost every release, so if you have something you want added, please let us know and we will likely add it. Finally, if you find a way to crash iolite via Python, please let us know. It may be a problem with your code or with the API, but we will only know for sure if you report it and we investigate. Now equipped with some basic knowledge of the Python language and packages, as well as iolite's API, we can turn our attention to writing Python-based plugins for iolite. Indeed, the remainder of the course is focused on writing different types of plugins for iolite, and in each week we will teach the code requirements, new relevant parts of the API, as well as any helpful third-party packages. There are some things that are common to all plugins that we will now quickly review. iolite will look for the different plugin types in particular folders that can be configured in the preferences. To check what these paths are, or to change them, simply go to iolite's preferences, and then click the Paths item on the left-hand side. Here you will find an entry for each of the main plugin types. If you click the Folder button, you can select a new path, or if you click the arrow button, that folder will be opened in Explorer or Finder. iolite comes with a plugin manager that provides a list of all the plugins it found during startup and whether or not it was able to load them, and some additional metadata. Notably, you can choose to disable a plugin if, for example, you wanted to turn off one of the built-in importers and use a custom Python-based importer that would match on the same file. To access the plugin manager, you can go to the Tools menu, and then Plugins, and then Manage. Here you can search using the input in the top left, and enable or disable plugins using the button here. Note that you will need to restart iolite to reflect any changes you make. There are multiple ways to create a new plugin for iolite. Perhaps the most basic is to simply navigate to the path specified in the preferences and create a new Python file in that folder with the appropriate metadata and functions. We do also provide a way in the user interface to create a new plugin via some built-in templates. These can be helpful because they already have the required functions defined with ample comments and only require you to modify the implementation as you see fit. To create a plugin this way, go to the Tools menu, and then Plugins, and then Create. In the dialog that appears, you can specify the plugin type, a name, a brief description, and the authors. And you can check this box if you want to open the Python file in your default editor. You can now find the plugin in the user interface and begin to use it. Every plugin begins with a bit of metadata. This information helps iolite sort out how to hook it up in the user interface and display useful information. A typical header might look as shown here, where the important bits start with a number or pound sign, followed by a slash, and then the metadata name followed by a colon and the metadata value. Each plugin type has a set of required functions and provides certain objects to the script environment, but these will be discussed week by week as we encounter them. That concludes our introduction to Python packages, iolite's Python API, and plugins in iolite. If you have any questions, please visit the relevant thread on the forum at forum.iolite.xyz. Bence will now take you through an example importer and discuss this week's exercise.